Two small submarines are sinking into total darkness, and the men inside them have no idea what they are about to find. It is the summer of 2008, and a pair of Russian deep-sea vehicles called Mir-1 and Mir-2 are descending into a lake so deep that sunlight disappeared hundreds of meters above them. These are the same submersibles that once filmed the wreck of the Titanic on the floor of the Atlantic. Now they are pointed straight down into the middle of Siberia, heading toward a place no human being has ever seen with their own eyes. When they finally reach, the bottom? More than a mile beneath the surface, what the pilots report back changes the way scientists understand this lake forever. And the strangest part is this: what they found down there should not exist in a lake at all. This is the story of Lake Baikal. And what happened when scientists finally reached its bottom is stranger than almost anyone expected. Baikal sits in the south of Siberia, in a remote stretch of Russia close to the border with Mongolia, cradled by mountains that stay snow-capped for most of the year. On a map, it looks like a long crescent, curved and narrow, stretching for more than 600 kilometers. From a plane, it could almost pass for an inland sea. That impression turns out to be more accurate than most people realize, and we will come back to why in a moment. But first, the numbers, because with this lake, the numbers alone are hard to believe. Baikal reaches a maximum depth of around 1,640 meters, which converts to roughly 5,387 feet. That is more than a mile of water stacked directly on top of the lake bed. For comparison, the average depth of the entire Atlantic Ocean is about 3,600 meters, so Baikal is not an ocean, but it is deep enough that a large portion of the ocean floor around the world sits in shallower water than the bottom of this one lake. If you dropped most skyscrapers on Earth into its deepest point, they would disappear completely, and you would still have well over 1,000 meters of cold water above them before reaching the surface. Depth is only the beginning of what makes Baikal unusual. Geologists estimate the lake is somewhere between 25 and 30 million years old, which makes it by far the oldest lake on the planet. Almost every other lake you could name, from the Great Lakes of North America to the lakes of the Alps, formed within the last few thousand, or at most a few 100,000 years, mostly carved out by glaciers during the last ice age. Glacial lakes are geologically short-lived. They fill in with sediment and vanish within a relatively short window of time on a geological scale. Baikal has survived for tens of millions of years because it did not form from a glacier at all. It sits inside a rift, a place where the Earth's crust is actively splitting apart, and that rift keeps the lake basin sinking faster than sediment can fill it in. We will return to that rift later because it turns out to be central to one of the most remarkable predictions scientists have made about this lake's future. Then there is the water itself. Lake Baikal holds close to 23,000 cubic kilometers of fresh water, which works out to somewhere around 20% of all the unfrozen fresh surface water on Earth. To put that another way, one single lake in southern Siberia contains more water than all 5 of North America's Great Lakes combined. If every other source of liquid fresh water on the planet disappeared tomorrow, Baikal alone could theoretically supply the entire human population for decades, and this water is extraordinarily clear. In winter, when ice locks over the surface, visibility has been recorded at more than 30 meters down, and in some spots closer to 40. That clarity comes partly from the lake's low mineral content and partly from something living inside it, which we will get to shortly. Baikal is also officially recognized as the largest freshwater lake on Earth by volume, even though it is not the largest by surface area. Lake Superior, for instance, covers a larger surface, but because Baikal is so extraordinarily deep, it holds far more water overall. The lake is fed by more than 300 rivers and streams flowing down from the surrounding mountains, yet it drains through only one outlet, the Angara River, which eventually joins the Yenisei on its long journey north to the Arctic Ocean. That single, narrow outlet, combined with the enormous volume held in the basin, means water entering Baikal today will, on average, stay inside the lake for several centuries before it ever leaves. In 1996, UNESCO recognized the lake as a World Heritage Site, citing both its unmatched biodiversity and its unique geological history as a still-forming rift basin, a designation shared by only a small number of freshwater sites worldwide. All of this made Baikal a magnet for scientists for well over a century. But for most of that history, the deepest parts of the lake stayed completely out of reach. You cannot free dive a mile down, and ordinary equipment cannot survive the pressure or the cold at those depths. For decades, the floor of the world's deepest lake was essentially as inaccessible as the floor of the deep ocean, mapped only in rough outline by sonar, its details left to guesswork. That changed with the Mir expeditions. In the summer of 2008, a team from the Russian Academy of Sciences, working with the P.P. Shirshov Institute of Oceanology, and led by the scientist Anatoly Sagalevich, brought the 2 Mir submersibles to Baikal for the first time. These were not experimental prototypes. The Mir subs had already completed more than 1,000 dives around the world, exploring hydrothermal vents on the floors of the Atlantic, Pacific, Indian, and Arctic Oceans, and they were rated to withstand pressures found at depths of 6,000 meters, far beyond anything Baikal could throw at them. Bringing that kind of proven deep ocean hardware to a freshwater lake was itself unusual. Lakes are not typically considered mysterious enough to justify this level of engineering. Baikal was the exception. On the 29th of July 2008, one of the Mir submersibles touched down at the lake's deepest point, reaching a depth of 1,680 meters, which was around 40 meters deeper than the scientists had originally expected based on earlier sonar surveys. The mission continued in stages over the following 2 years, with dozens of dives conducted through 2009 and 2010, and what the pilots found down there did more than just satisfy curiosity. It rewrote some of what scientists thought they understood about how this lake works. The first surprise was geological. Along the western and eastern slopes of the lake, the submersibles gave researchers a direct visual look at active tectonic faults, the same kind of fracture zones typically studied on the deep ocean floor at the boundaries of tectonic plates. Baikal, it turns out, behaves geologically less like a typical inland lake and more like a young ocean basin in the earliest stages of formation. This fits with what geologists already suspected about the rift beneath it, but seeing the fault lines directly, rather than inferring them from surface measurements, gave researchers a much clearer picture of how the basin is actively deforming. The second discovery was even more unexpected. Near a site called Gorovoy Utes, roughly in the middle of the lake, the Mir crews found seeps of oil and natural gas rising directly from the lake floor. Free-flowing crude oil seeping naturally out of the ground beneath a freshwater lake is not something scientists expect to see, and Baikal remains one of the very few freshwater lakes on Earth where this has been documented. At even greater depths, the team began recovering samples of gas hydrate, a strange ice-like solid formed when methane gas becomes trapped inside a lattice of frozen water molecules under intense pressure and cold. Gas hydrates are well known from the deep ocean floor, where they form in what's called the hydrate stability zone, but finding them in a freshwater lake was far rarer and far less expected. Researchers had detected hints of hydrates in earlier borehole drilling beneath the lake bed, but the Mir dives allowed scientists to see and sample them directly for the first time, confirming that Baikal's floor holds a genuine reserve of frozen natural gas, locked away by pressure and cold in a place no one expected to find it. Alongside the hydrates, the expeditions confirmed something else: active hydrothermal venting on the lake floor, cracks where warmer mineral-rich water rises up from within the Earth's crust. Hydrothermal vents are one of the defining features of mid-ocean ridges, the volcanic seams that run along the bottom of the world's oceans, and finding equivalent structures inside a landlocked lake was one more piece of evidence that Baikal is not behaving like an ordinary body of fresh water. It is behaving like a rift zone, because that is exactly what it is. None of this would matter as much if Baikal were geologically inert and lifeless. It is neither. Because the lake has existed in near total isolation for tens of millions of years, the animals living inside it evolved along their own separate track, cut off from the rest of the world's freshwater ecosystems. Scientists estimate that well over half of the roughly 2,500 to 2,600 known species and subspecies in Baikal exist nowhere else on the planet, one of the highest concentrations of unique or endemic species found in any lake on Earth. The most famous resident is an animal that, on paper, has no business being there at all. It's a seal, with the same round body and dark, wide-set eyes you would expect from any seal you have seen on a coastline or an ice floe, except this one lives more than 1,000 kilometers from the nearest ocean. It is called the Baikal seal, or Nerpa, and it is the only species of seal on Earth that spends its entire life cycle in fresh water. How a marine mammal ended up isolated in a landlocked Siberian lake is still debated among researchers. The leading explanation is that the ancestors of the Nerpa swam inland along a network of ancient rivers connecting to the Arctic Ocean, likely during a warmer interglacial period, and then became cut off as the geography and climate shifted around them over the following ice ages. Genetic studies suggest the Nerpa's closest living relative is the ringed seal of the Arctic, which supports this river migration theory, though the exact timing and route remain an active area of research rather than settled fact. Just as strange is a fish called the golemyanka, or Baikal oilfish. Its body is almost entirely translucent, so pale and see-through that internal organs are visible if you hold one up to the light. Nearly a third to over half of its body mass, depending on the individual and the season, is made up of fat and oil, an adaptation that helps it manage the crushing pressure and near-freezing temperatures of the deepest parts of the lake. Unlike the vast majority of fish species, the golemyanka does not lay eggs. It gives birth to live young, and it is believed to be the only fish in the world capable of living and reproducing across the entire depth range of the lake, from the surface down to well over 1,000 meters. Enormous numbers of these fish drift through Baikal's water column, and they form the primary food source for the Nerpa seals, tying together an entire food web built almost entirely out of species that exist only in this one lake. There's also the matter of why the water stays so clear despite over 300 rivers flowing into it. A large part of the answer is a tiny endemic crustacean called Episcura baikalensis, a freshwater copepod found only in Baikal, present in the water in staggering numbers. These animals continuously filter plankton, bacteria, and organic debris out of the lake, acting as a natural purification system running around the clock. Researchers have credited Episcura with playing a major role in keeping Baikal's water among the cleanest and clearest of any large lake on the planet, a kind of self-maintaining filtration system that took millions of years to evolve. Around the hydrothermal vents, the Mir submersibles found something equally striking: clusters of organisms living off chemosynthesis rather than sunlight, meaning they derive energy from the chemical reactions in the vent water itself, rather than from photosynthesis. This is the same basic survival strategy used by tube worms and other organisms found around hydrothermal vents on the deep ocean floor, and its presence in a freshwater lake added further weight to the idea that Baikal's ecosystem, in its deepest reaches, has more in common with an ocean than with a typical inland lake. Beyond the seal, the oilfish, and the vent communities, Baikal's shallower waters host their own catalog of unusual life. There are sponges that form thick, branching underwater forests along parts of the lake bed, giving certain stretches of the floor an almost reef-like appearance, despite being hundreds of kilometers from any ocean. There are more than 250 species of amphipods, small shrimp-like crustaceans, filling ecological niches that, in most lakes, would be occupied by only a handful of species. Some of these amphipods have evolved into active predators that hunt other invertebrates along the lake floor, an unusual role for animals that are typically scavengers elsewhere in the world. Researchers studying Baikal often describe its ecosystem less like a single lake and more like an entire miniature ocean's worth of evolutionary experiments, all packed into one basin, because nothing ever forced the lake to reset or drain the way glacial lakes elsewhere in the world periodically do. Now, on top of all this, there's a project happening in Baikal right now that has nothing to do with biology or geology and everything to do with astrophysics. Since 2016, an international team of physicists has been building something called Baikal GFD, short for Gigaton Volume Detector, on the floor of the lake's southern basin, roughly 4 kilometers from shore at a depth of around 1,360 meters. It is a neutrino telescope, an array of thousands of light-sensitive optical modules strung across dozens of cables anchored to the lake bed, designed to detect the faint flashes of light produced when high-energy neutrinos from deep space collide with water molecules. Neutrinos are subatomic particles that pass through almost all matter without interacting, which makes them extraordinarily hard to detect, but also makes them one of the only ways to study violent astrophysical events, like the aftermath of exploding stars or the environments around supermassive black holes, without that signal being scattered or absorbed on its way to Earth. Scientists chose Baikal for this project, for the same reasons that make the lake so extraordinary in every other respect. Its water is exceptionally clear and, at those depths, permanently dark, which is exactly what is needed to detect the faint Cherenkov light given off during a neutrino collision. As of the early 2020s, Baikal GVD had grown to include thousands of optical modules across dozens of strings, making it one of the largest neutrino telescopes on Earth, alongside its counterpart at the South Pole, IceCube. In the years since deployment, the detector has recorded high-energy neutrino events consistent with a genuine flux of cosmic neutrinos, matching independent measurements taken by IceCube on the opposite side of the planet, and it has flagged neutrino candidates, potentially linked to known deep space sources, including one event associated with the direction of a distant blazar, a type of galaxy powered by a supermassive black hole. In other words, one of the deepest, oldest, strangest lakes on Earth has quietly become a functioning window into events happening billions of light years away, a use nobody could have predicted when the lake first formed tens of millions of years ago. Building a telescope like this at the bottom of a lake is not simple. Every winter, when the ice covering Baikal grows thick enough to safely support heavy equipment, engineering teams drive out onto the frozen surface, cut access holes through the ice, and lower new strings of optical modules down into the water below, cable by cable, anchoring them to the lake floor before the spring thaw makes the ice unsafe to work on. It is a strange image to picture physicists in cold weather gear standing on top of a frozen lake in the middle of Siberia, carefully feeding astrophysics equipment down through a hole in the ice, all in pursuit of particles that began their journey toward Earth long before human civilization existed. Each winter, the detector, grows a little larger, and each year it gathers a little more data, slowly building one of the most sensitive instruments on the planet for observing the most energetic events in the universe, using nothing more exotic than lake water, darkness, and depth. None of this scientific attention has come without concern for the lake's health. Baikal has faced real environmental pressure over the decades, most notably from a pulp and paper mill that operated on its southern shore for nearly half a century, discharging treated industrial waste directly into the lake before it was finally shut down in 2013, following years of pressure from scientists and environmental groups. Researchers have also tracked outbreaks of toxic algae in some near-shore areas, linked in part to nutrient runoff from tourism and settlement along the coastline, along with a mass die-off of Baikal sponges tied to disease and changing water conditions in the 2010s. None of these issues threaten the lake's overall volume or depth, but they are a reminder that even a body of water this vast, this old, and this resilient is not immune to pressure from the world around it, and conservation groups continue to monitor its water quality closely given how much unique biodiversity depends on keeping it clean. Above the surface, Baikal has its own kind of spectacle, and it happens every single winter. For roughly 4 to 5 months of the year, the entire lake freezes solid. Because the water is so clear and so low in sediment, the ice that forms on top of it is often almost glass-like in its transparency, thick enough in places to have once supported roads and even a temporary railway line laid directly across the frozen surface during the Russian Civil War, when engineers built a rail crossing over the ice to move troops and supplies. Beneath that ice, methane gas rising from the lake bed sometimes freezes in place as it reaches the surface, forming columns of trapped bubbles that look like strings of pearls suspended in the clear ice. In other places, shifting currents and wind push broken ice upward into jagged ridges called hummocks, walls of pale blue ice that can rise well above head height, drawing photographers from around the world every winter. A lake this old, this remote, and this strange has naturally accumulated its share of folklore. Local communities around Baikal have long told stories of strange lights beneath the ice and unexplained shapes moving in the deep water, and during the Soviet era, unverified accounts circulated of military divers encountering something they could not identify or explain in the lake's depths. It's worth being honest about these stories rather than dressing them up. None of them are supported by credible scientific evidence, and the more dramatic versions involving humanoid figures or unidentified craft belong firmly in the realm of folklore, not documented research. What is genuinely true, and arguably more interesting than any legend, is how much of Baikal remains unexplored even now. New species are still being described in its waters on a regular basis, and researchers continue to map sections of the lake floor that have never been directly surveyed. The lake also holds deep cultural significance for the indigenous Buryat people who have lived along its shores for centuries, along with earlier Evenki communities in the region. In Buryat tradition, Baikal is often referred to with reverence close to that of a living being, sometimes called the Sacred Sea, and Olkhon Island, the largest island on the lake, is considered one of the spiritual centers of Central Asian shamanism, home to sites still used for ceremonies today. That reverence isn't just cultural decoration, it reflects a genuine, long-standing relationship between the people who live along Baikal's coastline and a lake that has shaped the region's climate, economy, and daily life for as long as anyone can trace back. Which brings us back to the rift running underneath the entire lake. Baikal sits at the center of an active continental rift zone where the Earth's crust beneath Siberia is slowly being pulled apart. GPS measurements show the two sides of the rift widening by a small amount every year, typically cited as somewhere in the range of a few millimeters to around 2 centimeters annually, depending on the specific location and measurement method. On a human timescale, that's barely perceptible. On a geological timescale, it's significant. If this rifting continues at anything close to its current pace over the coming tens of millions of years, some geologists propose that the Baikal Rift could eventually widen enough to allow ocean water to flow in much the same way the East African Rift is expected to eventually split the African continent and give rise to a new ocean basin over a similarly long time frame. This isn't a settled prediction, it's a long-range hypothesis built on present-day tectonic movement, and a lot could change over tens of millions of years. But it means the lake we see today, however vast it already seems, may only be a very early chapter in a much longer geological story. Put all of this together, and Baikal stops looking like an ordinary lake anywhere on the map. It is a rift valley slowly tearing itself open, filled with a fifth of the world's fresh water, old enough to have grown its own entirely separate branch of evolution, deep, enough to host oil seeps, methane hydrates, and hydrothermal vents on its floor, clear enough that scientists chose it as one of the best places on the planet to catch light from exploding stars on the other side of the universe, and calm enough on its frozen surface every winter to look, for a few months, like a solid sheet of glass stretched over a bottomless void. The Mir expeditions gave us our first direct look at what was hiding down there, and what they found confirmed that this lake behaves less like a body of fresh water and more like a young ocean still being born. If a story like this is the kind of thing you want more of, subscribe to the channel so you don't miss what we uncover next, and drop a comment letting us know which corner of the planet you'd like us to explore in a future video. And if you're curious about that other rift I mentioned, the one splitting open in East Africa and expected to eventually form a new ocean of its own, go check out the video linked on screen right now, because these two places, thousands of miles apart, are really telling the same slow, powerful story about a planet that never actually stops changing.